another inequality here, but this time instead of doing the intercepts, let's do slope-intercept. So I want to get y by itself. So the first thing we're going to do, we're going to subtract 3x from both sides. And we're going to get 4y is less than or equal to negative 3x. Divide by 4. Y is less than or equal to negative 3/4 x. Now we're going to graph that. And notice my y-intercept is 0. And my slope is down 3 to the right 4. And it's a solid line, so I want to make a solid line going through this. And I didn't draw that very well, so I'm going to redraw that. Well, I'm just not very good at that. Okay. Meh. Try that again. Okay, that's a little bit closer. Now the nice thing is when you write it in slope-intercept form, you can just look at the inequality. My test, now by the way, if I pick a test point, don't pick 0, 0, because 0, 0 is on the line. It'll be true no matter what. So what I'm going to do is I'm going to look at that. It less than means below my line. I can't do that when it's in standard form, but I can do it when slope-intercept form. And when I say below, I mean vertically. So I'm going to go down from my line, and that's the section of the graph I'm going to shade. So I'm going to shade below my line, and that's going to give us our inequality. So you might think you always want to put it in slope-intercept form because it's easier, but not all the time. Sometimes it's harder to graph in slope-intercept form, but that one was a nice one. Here's an example where I won't put it in slope-intercept form because I got some really ugly numbers to get the slope. Emory can spend up to, remember up to means less than or equal to $20. And to provide her dance squad with drinks after the practice. A bottle of water costs 80 cents. And a sports drink costs $1.25. So I think what I'm going to do is I'm going to define my variables. I'm going to let X be the number of water bottles she can order. And Y would be the sports drinks. Pretty cheap. Probably should update this, although it's a brand new textbook. So we're going to say 0.8x. Well, maybe she gets a discount. So 0.8x plus 1.25y has to be less than or equal to 20. Do you see why I don't like slope-intercept form here? Because we got decimals galore. So let's just do our intercepts. So my x-intercept is going to be 0.8x equals 20. I'll divide by 0.8. So 20 divided by 0.8. Let's use our calculator here. So 20 divided by 0.8 is 25. So she can buy 25 bottles of water. Only water. And so notice my graph only goes up to 20. So let's count by, let's count by twos. So here's my bottles of water. So there's 2, 4, 6. I'm going to make this bigger. You can't make it bigger, but I can. Makes it easier to write with. 8, 10, 12, 14, 16, 18, 22, 24, 26. So there is our bottles of water. And then let's find the y-intercept. So my y-intercept, I'm going to say 1.25y equals 20. So we divide by 1.25. So 20 divided by 1.25 is 16. In that one, I can just put in, these are sports drinks, aren't they? And then I started writing bottles of water. So I can put in my sports drinks, and I can count by ones on this one because my graph goes up to 20. And since it's less than or equal to, I'm going to draw a solid line. And then I'm going to shade beneath that. Now, notice I stop because can I have a negative number of bottles? No, I can't. So when you do your assignment, they might say, oh, you've also got a graph like x is greater than or equal to 0 and y is greater than or equal to 0. But when we're doing it just on paper, we can see what we need to graph. Now, you got these choices, but remember, you can't have a decimal number. So although there are decimals in our graph, we can't have a decimal number. So she's got a whole bunch of choices. We know 25 bottles of water and 0 sports drinks is an answer. And 0 bottles of water and 16 sports drinks is an answer. I could pick any point on here, like 10 and 3. That would work. Just as long as she has enough for her sports team.